So this is the assignment which we have. It's basically the creation of a cylindrical plate. Cylindrical plates in COMOSYS are used to, it's like folded plates, but more complex, more involved. And the idea is that at the end you can create your unfolded drawings, like you can see over here. So that's the purpose why we create cylindrical plates. Now the way, so what the exercise is saying is that you need to model this cylindrical plate, and it says model 4 separate plates. These are contour plates, by the way. So you basically the way you build up a cylindrical plate is you model contour plates separately for each part, and then you basically join them together by using the cylindrical plate command. So all plate thicknesses are 8 millimeters. The bending radius along the center line, this is important, along the center line is 12 millimeters. If you note over here, if you zoom in, this is the sectional view of the cylindrical plate. The radius on the inner radius is 8 millimeters. The outer radius would be 16, and the middle radius is what we will need, as that will be 12, so 8 plus half of the thickness. That will be 12 millimeters. That's given over here as well. And so what you will do is we will basically first create these 4 contour plates like this. All the dimensions are given, and this part should be easy for you because just entering contour plates with given dimensions is very easy. And then once we have these plates, we will use the cylindrical plate command, and that's the purpose of this assignment, to learn how to do that. The top view of the cylindrical plate is given, the side view of the cylindrical plate and the 3D view of the cylindrical plate are given over here. And the separate plates are also drawn in 3D view over here, because this is where it will start. And the 4 plates from the side, when it's still in the form of 4 plates, are also drawn out over here. And using this information, we will be modeling the cylindrical plate. So here in the model, you can see that I have created those 4 contour plates like that. Let's just turn off the handles. So this is one plate like that. And this is the second plate. This is the third plate, and this is the 4th plate. They've been modeled separately. If I zoom in, you can see that it's touching it like that from the back side. Let's zoom in. Basically, the bottom part is connecting over here. You can see how they're oriented. So there's 4 plates which you will need to model. I will not be showing how to model those plates. Those are pretty simple. I mean, you can just model them using direct entry very easily. This will be a contour plate with these 2 slits, and then you will have this one and this one and this one. And once you have this ready, probably it's going to take you 1 or 2 minutes to just do that. Then you will be ready to actually work with the assignment, which is converting these 4 contour plates into a cylindrical plate. So to convert these 4 into a cylindrical plate, it's done one by one. What we will do is we'll go to the steel menu, and under this menu, the sectional plate, you have the cylindrical bent plate option. And if you click on keep the shift key pressed to turn on the settings, we will need to give a thickness to this to the final cylindrical plate. Now it doesn't take those thicknesses from the source plates, because maybe it assumes that you might want a different thickness for the cylindrical plate. So I'm just going to enter 8 millimeters for that as well. And for the radius of the bending between these contour plates, I will give a 12 millimeter bending radius, because what it's asking over here is the center line. Is the center line bending radius, not the inner one, or neither the outer one, but the center line one. So giving that, you can give the resulting plate any material if you want. And so you do these settings first. You can save them away as macro presets as well as usual. So apply and OK. So your settings are ready. So how do you actually use it? You go to the sectional plate. You click on this button. Then you select any 2 of these. So for example, I'm going to select this one and this one. And the moment I do that, if you notice, let me just right click and end. If you notice, I have a different object now. If you notice, those two have been joined together according to that given radius and thickness as well. We have a little gap over here because this was coming at an incline. So when it hit that point, it needed to end earlier. So this is the default behavior. We'll come back to this in a second. Let's continue with the other connection. So now we have one cylindrical plate. This one is, if you notice, the handles are different. And we still have two contour plates left. So we go back to the cylindrical plate command. This time we select an existing, so the way the command works is you can either select two contour plates or you can select one existing cylindrical plate and a contour plate, which will add that to the existing one. So I select this one and then I select this, this contour plate, and that one also gets added to that. Don't worry about why this is looking like this. We'll just get to that. And for the final one, we select this one and this one. And once again, we have now converted all the, let me right click and finish. What we've done is we've converted all the contour plates into cylindrical plates. Now the cylindrical plates have their own handles. So when you click on it, you will see several handles, and these hexagonal circle-like or hexagons which you see actually represent the original contour plates. So for example, if I click on this one, you see the handles will change. It's going to now select the handles of the original contour plate. So I can actually make modifications over here as well. Or if I select this hexagon, it's going to bring in the handles of that original hexagonal contour plate, that original contour plate. If I select this one, then that one, and if I select this one, then the big plate. But the ones I want to use right now are none of those. You also see these lines over here. These lines are what represent the folds. This one, so there are three folds. This line represents the fold between this and this, and similarly this line represents that fold. So we are now going to worry or focus on what we saw over here, these little gaps. So let me select this line, which represents the fold between this one and that one. And there are several options over here. One is to bend according to the shorter edge, bend according to the longer edge. Then one is which basically makes sure that both the edges of the two plates which are involved, they get there's a uniform transition between the two from both sides. So that's what I want. So if I click on this one, you will notice that it's now a smooth transition from that point to that point. The other side was okay in any case, but because of this inclined cut, we were having that problem. But now that we have invoked the smooth transition option, we get this result. Now we can click on this line, which represents the bending between this plate and that one. And on this, both sides are slightly off, this side as well as this side. So once, all I need to do is just click on this button, and that one also gets corrected from this side, and you can see from the other side as well, like that. And finally, all I need to do is just select this line, which represents the bend between these two, and click the same option. And that will basically bring my cylindrical plate to the desired point. Now, these transitions between the plates will obviously depend upon how you initially enter them. And maybe you can find another alternate way of entering in which the transition is smooth to begin with. But in any case, this is what the eventual geometry will look like. And if these lines, which basically represent the transition from there to there, bothering you, is in the sense that you don't want to, I mean, it makes the model look a bit odd. What you can do is you can click on because this is to do with the threshold at which these lines are removed. So what you can do is you can keep the D key pressed while double clicking on the cylindrical plate, and go to the general tab, select the drawing layer, And for this edge removal threshold, enter a slightly larger number, and you will see that you will stop seeing those triangular transitional polygons over there on all sides, basically. But like I said, this transition will depend on how you've entered the initial plates. Now, like I said, when you select the cylindrical plate, these lines represent the bends and these hexagonals represent the original contour plates. So you could, for example, if I selected this line, the bend between that one and that one, while you could use these ones, we've already used this one, we could also change the bending radius, which was 12 millimeters. But if you click on this R over here, it shows the 12. If I make it 25 and say OK, you will see that it's now bent at a larger radius, which you can see from the other side as well, like that. So those handles can now be used to modify the initial radii as well. Let me just press Ctrl Z to undo that. What you could also do is select the plate, for example, and let's say I want to make a change to this original plate, the big one. So I select this hexagon, this one over here, which represents that plate. I click on that, and the moment I click on that, the handles of that plate, as it was originally drawn, appear on the screen. And for example, what I can do is I can select this particular corner and give it a chamfer, for example, of maybe, I don't know, 50 and 50, let's say, something like that. So my cylindrical plate is now modified according to that chamfer. I can similarly modify the other plates as well. So basically what I need to do is I can just select it. Obviously this is not part of the assignment. I'm just explaining the command a little more. So we could select this one, for example, and then move its handles around, or insert new points as well. So I could select this middle one and actually insert a new point in this cylindrical plate. And I could even add new plates to it. If I wanted to add another contour plate over here, I would just need to go back to the cylindrical plate command and add that plate to the existing one. So very easy to use. You can change the radii, you can modify the original plates, you can add new plates. If you want to remove a particular one, that's also possible. So all you would need to do is, for example, select this handle. If you, let's say you wanted to remove this plate altogether from the cylindrical definition, you would just click on this bending line and you would click on this cross button over here. And that's what it's going to do is it's going to remove that from the definition of the cylindrical plate, and it will leave that as a separate contour plate just in case you want to put it back. So this is a nice command to have. The advantage, like I said, if you go back to the drawing, is once you create cylindrical plates, you can create the unfolded drawings of those plates as well, as you can see on the screen.